Hello students, in the last class we discussed about the differential centrifugation. Today we will discuss about density gradient centrifugation. Okay, this is the second type of centrifugation, that is the density gradient centrifugation. Okay, in the density gradient centrifugation, the density of the medium increases from top to the bottom. Here the medium plays important role in the centrifugation, and the density of the medium plays important role in the centrifugation. Okay, है ना? So that means कि density of the medium increases from the top of the from top to the bottom. Okay, that means कि if this is the test tube and here is the medium for centrifugation, the density of the medium gradually increases from top to the bottom. It will be minimum here and maximum here. Okay, and it will move from top to the bottom. And this increase in density of the medium is brought about by increasing the concentration of the solute of the solution medium. Okay, so this medium in the medium, the increase in the concentration is brought about by increasing the concentration of the solute for the solution. Okay, the concentration of the solute will be minimum over here and maximum over here, and in between different concentration will be present. Okay, so this is the basic idea of the density gradient centrifugation. One is the increase in the concentration of the medium, density of the medium by increasing the concentration of the solute. Okay, है ना? So then in the density gradient medium, there are two types of density gradient medium. One is continuous gradient medium centrifugation, and second one is the rate zone centrifugation. That means the density gradient centrifugation is of two types: continuous gradient centrifugation and rate zone centrifugation. So today we will discuss about the continuous gradient centrifugation. Okay? Continuous gradient centrifugation is also known as isothermal centrifugation. Okay? In the continuous, as the name suggested, the density increase in the density of the medium is uniform, continuous. Okay? Okay? The increase is very uniform, है ना? Continuously increasing from here to here. Okay? So that first point is the density of the medium increases uniformly from top to bottom, है ना? And another point is that the separation of the particle occurs according to their point density. The higher it is the point density, okay, and different point density particle will move different distance, okay, and they will get separated. And another point is that suppose this is the increasing concentration, the particle moves down the medium towards the bottom of the centrifugation tube at the centrifugation starts. Okay, the movement of the particle will cease at that point where the density of the medium equals its own density or equals the density of that particular particle. Suppose a particle very least density will moving down the solution medium, okay, and when it moving this to this point, its movement will cease, or the particle stops over here. Okay, that means this very point has a density equal to that particular particle. Suppose a particle is moving down the medium towards the bottom, and it moves this very distance and it stops here. the particle stops here, that means K density of the medium at this point has equal density or equal in the density of that the medium is equal to the density of that particle. Okay, and that portion is known as isopycnic point. That means the all the particles, suppose K, this is the particle A, it moves here and it stops here. So this portion, this point is isopycnic point for this A particle. Okay, and another particle, it has a higher density, will move this distance and reaches its isopycnic point. That means that this point of the medium has a density equal to that B particle. Okay, so this B particle will stop here and it will form a band over here, and the A particle will form this band over here. Suppose a C particle, it is the heaviest particle, and this will move a larger distance, and after reaching its isopycnic point over here, this particle will stop over here. That means that all ABC are present in the solution when centrifugation starts. The least particle of least density will stop here at the top of the test tube, and the particle B, suppose it has a density greater than that of A, will move here in the middle of the test tube and form a band under here, and the C particle, which has the maximum density, will move maximum distance and reaches its isopycnic point here and form a band. That means that all the particle ABC which is present in the sample will form three different bands. 1, 2, 3. These bands indicates particle of least density, this of medium density, and this is for maximum density. Okay, so if the sample is put over here and in a medium which whose concentration, whose density increases continuously, by a continuous increase in the concentration, and for that cesium chloride is generally used. 20% to 70% cesium chloride solution is used. So this is the cesium chloride solution. Over here, uniform concentration. This means the concentration of cesium chloride is 20% at the top and 70% at the bottom, and in the middle the 21 to 69% of the solution is present in a continuous manner. Okay, the solution is put over here at the top, centrifugation starts, and then all the particles present in the sample will form three different, although suppose three types of particles are present, they will form three discrete bands of their at their isopycnic points. That means this is the smallest lightest particle having the least density. This has the density. This band has a dense particle this is the band of particle having a density greater than this one, and this has the maximum density. Particles having the maximum density. But by the end of the centrifugation, we get different bands of particles, and all the bands are formed at their isopycnic point. Okay, that is why it is known as isopycnic centrifugation. Okay, that means you understood. Okay, this is the solution. Here the sample is put, centrifugation is started, and at the end we get three different bands of different particles having different density. Here the particle, all the particles having a density equals to that very point. will stay over here and form a bond band. Here all the particles have a density equal to the density of the medium at this point. Okay, and they will stay over here and form a band over here. Okay, and this is the particle. In this particle whose density equals the density of the medium at that point, will form a band over here. Okay, so all the bands are present, all the bands of the particle are present, are formed at the isopycnic point. That is why it is known as isopycnic centrifugation. And then we get all the particles having different density will form different bands and get separated from each other. So this is the basic idea of continuous gradient centrifugation, also known as isopycnic centrifugation. In the next class we will discuss rate zone centrifugation. Thank you very much.